So today we discuss pulley. Okay, a pulley is a very simple machine. Okay, pulley, simple machine. Okay, so what is pulley? Pulley is like a wheel. Okay, suppose there is a rigid support here. Okay, and there is a wheel. Suppose consider that is a wheel like that. That is a wheel. Okay, so that is a wheel. Okay. So very well, and that point is here a support from, I think it's not a joint part. Okay, okay, that is there is a wheel here, and that is the support here. Okay, so that is a fixed here. Okay, wheel is moving in that direction or in that direction. Okay, but here is a support. Okay, and that is a fixed support here. Okay, and here is a movable point. Okay, that is point is a rod present from in that direction to that direction opposite, like this. Is a fixed rod, rigid support, that is a support here, that is a wheels look like this. Okay, now that is a wheel. Okay, that's wheel, and that is a fixed support, and that is called axle passing through the wheel center. It is called an axle. Okay, here this point is called a rod. Okay, that is a rod. Okay, and that rod, one end is connected from that support and other end is connected from that support, and here that is the fixed inside that rod is called axle. Okay, and if that is a fixed point, there is suppose a nail hole, because the wheel movement in that. Okay, that is not slip here. Otherwise, in a running condition, the axle is, I think, goes out from that fixed that support system. Okay, that's why a nail or any spring or any other the sharp object put here. That's why axle at fixed position. Okay, that's not move. Okay, so that is a pulley system. The total is that a pulley. Okay, clear? Okay, now, okay, so here we discuss a fixed pulley, a single fixed pulley, or a mover pulley. First we discuss a single fixed pulley. Single fixed pulley. Okay, so if I marking this as a rigid support, okay, that is called also called a frame. Okay, that is a frame or support, that is also a frame, that is a frame. Okay, there is a nail. Okay, and there is a nail, sharp nail, I think that's one nail, that is a nail for support that system. Otherwise yeah, otherwise if I not put a nail here, I think axle is either goes at that direction or that direction when its wheel is moving faster than faster. Okay, that's why it's fixed. Suppose the bike rear wheel or front wheel, there is a axle is very important. I think a nut also to not also fix that support here. Okay, so a nail or nuts. So here we discuss the pulley in two ways: the single fixed pulley and single movable pulley. First, the single fixed pulley. What is the meaning of fixed pulley? Pulley. The pulley, if I draw here, that is a frame, rigid support. Okay, that is a pulley axle is stationary. Okay, means that total system at stationary. Position is not changed. Okay, means that is a stationary. Single fixed pulley means a stationary position of pulley is not change. Okay, so here the frame, okay, and that's a pulley. Okay, now some rope passing from that pulley. One end of the road is load in hang, there is a load, and other end of that rope someone pull that rope. Okay, someone try to pull that rope in that direction. Okay, in that direction. So we know that is a axle here. Okay, there is an axle. Okay, if load, we know that load also a force, type of force. Okay, so that is load also equal to W dot also equal to mg in that downward direction. Okay, so here is a rope, that's why the tension force, that is a tension force. Tension is the one type of force act on a rope. So if load goes downward, tension goes upward. A single rope means here also a tension in that direction, and here is an effort, so some person apply effort in that direction here. Okay, so if we apply the Newton third law here, Newton third law, we get applying Newton third law. Okay, third law. So tension also a force and load also force. Load goes downward, tension goes upward. From Newton third law, that is equal to load equal to tension. Okay. If I apply Newton third law here, okay, so effort also a force. Effort is a one type of force goes in that direction, and tension in opposite direction. Tension also one type of force. If one string or one rope means one tension. Okay, what is the tension? Tension force applied in that string is called tension force. Okay, okay. On string. Okay, force applied on string is tension. Oh, so here the tension also a force. So here we apply Newton third law. Here we get tension also equal to effort. Okay, next page. If we calculate the mechanical advantage of single fixed pulley, so you know that load by effort, load also a tension T, and effort also here, that is also a T, so that's a T. So cancel out this. So mechanical advantage is 1. And what is velocity ratio? Important. And we know the velocity ratio is the displacement of effort arm by displacement of load arm. Okay, see that diagram. If here is some person A pull towards the rope, and rope, I think, displace in that direction, rope end, this end displace in that direction. So here that rope, that end displace the DE, displace in that direction, and that's some unit, some meter here, some units, that's suppose the DE. Okay, suppose consider that is a 1 meter or 1 unit. So see that that is a rope, and a rope has a fixed length. If that fixed length, if rope this end displace 1 meter in that direction from left to right, so here the load goes upward, same length. Okay, same length and same displace here. That is also a 1 meter. So that end moves here, and like load now here. Load moves upward in displacement of 1 meter. So here that is the displacement of load. So displacement of effort is also 1 meter and displacement of load say that also equal to 1 meter, means I think I say that is a x meter displaced in effort and x meter displaced in load, both are equal, so cancel each other, so we get a 1, that is velocity ratio also 1. So you know that the from relation equal, know that mechanical advantage equal to velocity ratio times efficiency. So here the mechanical advantage by velocity ratio we get eta, and that is both are same here, so eta equal to 100%. Okay, so eta is a 100%. So if eta is 100% and here we know the mechanical advantage is 1, we get some conclusion here. Okay, it's an important conclusion. So pulley, a simple machine, is not a force multiplier. Pulley is not a force multiplier because mechanical advantage equal to 1, or nor speed multiplier because also ma is equal to 1. That's right. So what is a pulley? What is it used for? If we not use as a force multiplier, if we not use as a also a speed multiplier, so pulley used only to change the direction of effort to the be force applied. So what is the main purpose of pulley use? So to change the direction of effort, the direction of effort effort to be applied. Okay. Effort also force. Okay. Effort can apply more convenient direction, or so that effort applied more convenient direction. Clear? So see the diagram here. If effort in that direction, if it goes in that direction, so load also move upward. That is the effort. That is a load. That's very important. A maximum load put overcome that pulley. Okay, that's why the minimum actually that is not a force multiplier. So here the mainly important point here is that direction is important. Okay? Not a force multiplier, not a velocity multiplier, not a speed multiplier. Okay, clear? Next point is the next topic we discuss is the single movable pulley. If here we see that the pulley is fixed, position is not changed. If that wheel is that pulley is not goes upward, not goes downward. Okay, but in that case, pulley is moving. A single movable pulley, a single movable pulley. So what is a single movable pulley here? See, first we try to draw a diagram. So pulley here, as axis of rotation is movable. Actually here the axis of rotation is fixed. Actually key point is axis of rotation is fixed. So what is the axis of rotation? That is the axis of rotation. That is the axis of rotation. If we'll move in that clockwise or anti-clockwise or here in that direction, the axis of rotation is here. That is the axis of rotation. I think there is an axle length. Axle lie on that axis of rotation. Axle mean that axle is lie on that axis of rotation or parallel to axis of rotation. Okay, that is a very important point. Axle is the parallel to axis of rotation. Clear? Very easy. So here that single fixed pulley, the axis of rotation is fixed. But when you discuss the movable pulley, the axis of rotation is moved. So axis of rotation is moved either in that direction, top or bottom in that direction. Okay, position is not fixed here. Okay, position actually changed. So try to draw a diagram. A fixed support, rigid support here, fixed rigid support here. Suppose that is a pulley. And here that axle here, and that is a load, that is a load here. So that is a now thread, a rope is, that is a fixed support. Okay, that is a fixed support. Fixed support, fixed support. Okay, it's a raw ceiling. Okay, now that is a rope that is fixed at that end of the rope with fixed support, and that rope is moved downward here. Okay, so here we see the difference of two diagrams. That load is connected to one end of the road and other end of the rope is connected to the effort. Here one end of the rope is fixed or connected to the fixed support and other end is free. Okay, and here the axle point, axle to load is hanged, load hang from axle point. So here some person, okay, pull. Okay, so load is downward, so here is the tension force, so that is the tension force upward, and here also tension upward, and here we see the effort also in that direction, some person. Okay, from we know that uh, from applying Newton third law. Okay, so load is downward direction. If I Newton third law applied in that point, load goes downward, and two tension, the maximum means the one tension and two direction, that is goes upward. So that means a 2t, that means applying Newton's third law, 2t, that is equal to load, and here you apply Newton's third law here, at a effort also at that direction and tension also at that same direction, so that is tension also a force, effort also equal to force, effort equal to tension. So here the mechanical advantage equal to load over effort. So load means 2t, and what is the effort is a t, so cancel, that is mechanical advantage 2. Okay, that is very important. Now another important point here. So if that is a velocity ratio, what is the velocity ratio? Okay, what is the velocity ratio? Velocity ratio is that if uh, uh, see that if some person A pull that object string in that direction. Okay, if that direction means if I displacement of effort is like 1 meter. Okay, so that's why load moves, remember that, the half of effort. Okay, half meter. If effort moves here to that is 1 meter, so load moves half meter. Okay, that's a very important point. That is the distance is 1, suppose 1 unit, that is the load moves half unit. So here we see that velocity ratio is equal to displacement of effort by displacement of load. So displacement of effort is a 1 and displacement of load is half, so that is a 2. So velocity ratio also 2, mechanical advantage also 2. So what is the eta? So you know that ma equal to vr times eta. So eta equal to, both are same, so cancel each other, so 100%. But here important things. So that mechanical advantage 2 means that is a force multiplier. So force multiplier. So here the mechanical advantage, why? Because mechanical advantage is greater than 1. That's why this single movable pulley, so one end is fixed, that is called a force multiplier. Okay, but here the efficiency is 100%. Okay, efficiency is 100%. Okay, clear? But one thing, remember that we ignore that weight of that pulley. Okay, that's how we discuss only weight of that load here. Okay, now and efficiency always 100%. Okay, that means no loss, but there is a loss due to air or a friction, but ignore that losses here. Okay, now so here we discuss a one fixed and one movable pulley. So one fixed, let's draw a diagram, a system actually, a system, one fixed and one movable pulley. So one fixed and one movable pulley. So what is mean of one fixed? So try to draw a one fixed, that is a rigid ceiling. Okay. So fixed pulley means here the pulley fixed with here. Okay. And one movable pulley here. So draw that movable pulley. That is a one movable pulley. That pulley is movable. Okay. So here the load hanging from here. That is a load, and that rope is now connected like this. One end of rope is fixed here. So actually goes that and that and goes here, that here. That is a one single rope, and one end of rope is fixed here, other end is free here. Okay, and that's the blue color pulley is movable, move upward or downward, and here the blue color pulley is fixed pulley. And some person here, that person pull apply effort here. Okay, so very easy concept. If a load goes downward, there is a tension T upward. Here also a tension T. Okay, if applied effort in that direction, here also a tension T. In that direction, tension T. Now we apply Newton third law in that position. Newton third law. So applying Newton third law, apply Newton third law, we get load goes downward and 2 tension goes upward, load equal to 2T. Here Newton third law apply here, we get tension also equal to effort. From mechanical advantage, you know that load by effort, load equal to 2T and effort is a T, so mechanical advantage 2, so that is a force multiplier in that system of pulleys. And what is the velocity ratio? Okay, very important point. What is the velocity ratio? Okay, see that if someone try to pull rope in that direction, okay, we told in previous diagram, if effort in that direction means a 1, The expression of effort is 1 if load moves upward or downward. It's half of the applied is here. Now what type of length is here? Half of that length of effort. Similarly, see if that is a 1 meter here, suppose that is a displacement effort is 1 meter. So here also a 1 meter, that is 1. So that's 1 is now reduced here half. 1 reduced half because that 1 is also here displacement of 1. Okay, so that is a 1. So the first single fixed pulley concept here, if both are the same here, that is a if 1 meter here also 1 meter, similar concept here, that is a 1 meter also a 1 meter here, but here when the movable pulley concept, if 1 that is a half here. So displacement of load is half and effort is 1. So displacement of effort by displacement of load, that is 1. Displacement of effort, let's say that is 1 meter, that is a half 1 by 2. So that is also 2. Velocity ratio also 2, and here the efficiency similar, that is 100% if both M and V are the same. Okay, so that is a one fixed and one movable pulley. Also the mechanical advantage is 2, and here one movable pulley also give the mechanical advantage 2. So that is a, I think that is that a one single movable pulley is more cost efficient because there is a one pulley here. I think there is a more cost, that is a two pulley here. So actually you choose a more efficient way. Actually less cost we choose here. Okay, that's why single movable pulley is the best option. Okay. Now the important point is the comparison between single fixed pulley and single movable pulley. Okay. So here the comparison is, that is important comparison, difference between single fixed pulley and single movable pulley, and that is a so all single movable pulley. Okay. What is a single fixed pulley? Single fixed pulley is a fixed support. Is the position is not changed. For example, is position is not changed. Position is changed. Sorry, one position is changed. Is changed. Number two. So here is single movable pulley is the ideal because here the mechanical advantage is 1, but here mechanical advantage is greater than 1. They are also ideal, but mechanical advantage is more than 1. So here that velocity ratio also 1. Here velocity ratio also greater than 1. I think 2. Okay. So 1 means here ma equal to 2 we get, and we are also get 2. Okay. That is a 0.3. Number 0.4. Okay. Uh, actually is the direction. Okay. Direction change effort from upward to downward. Okay. A single pulley direction like that is a single pulley direction is up to down, effort applied in up to down direction, effort applied here, effort applied up to down direction, and number 4 effort applied down to up. Okay. 4 points, I think that is enough point. Okay. So next class we discuss combination of pulleys. Okay, today I end class here. If any doubt in that section, put in comment. I will try to give the answer. Okay, thank you.